Welcome to this session on the criteria for theories of consciousness. In this session, we will go through a relatively new concept in consciousness research, which is the criteria for theories of consciousness. So if you've seen the previous 4 sessions on the theories of consciousness, we went through the first order theories or recurrent processing theory, and we went through higher order thought theory or HOT, the global neuronal workspace theory, and integrated information theory or IIT, which are these 4 large theories out there on consciousness. The sessions were mostly theoretical, where we define what the theory predicts, what individual theories predict, and what they try to describe about consciousness. So the natural question is, which theory is best? Which theory has the most empirical data to support it? And here, the research field of consciousness is a bit different from other areas of science. There are so many theories out there. And this is pointed out in a recent article called The Hard Criteria for Empirical Theories of Consciousness by Doric and colleagues. And today we're going to be dealing with this paper mainly because we think that right now it is a very good illustration of the research field of consciousness. So in the paper by Doric, they state that all of these theories, for example, including these 4 theories that we went through, they have a different focus and a different approach. So for example, HOT has a focus on the PFC and is a very neurophysiological approach, whereas IIT, integrated information theory, had a more computational mathematical approach. And Doric points out that maybe there exists so many different theories, different approaches, and they point out that all these different approaches exist within consciousness research, and that is different from other areas of science, where you typically have 1 or 2 theories that you're comparing. In consciousness research, you have many different theories. So what Doric and colleagues propose is that this might be because there's a lack of stringent criteria or hard criteria for defining which theories of consciousness are best. They state that they will argue that consciousness can be defined and can actually be empirically researched, and it is therefore not impossible to figure out which theory of consciousness is best by doing experiments. And what they propose is this checklist of criteria that they propose can be used to validate which consciousness theory can live up to these criteria. Can they address or can they cope with these criteria? And they go through the paper and discuss 13 different theories of consciousness and ask if they can live up to these criteria. So in this course, we of course only looked at only 4 theories of consciousness, but in this paper there are 13, and you shouldn't worry about that, because the main point of this paper is that the research field of consciousness is at a point where we have so many different theories, but we also have a lot of empirical data and a lot of studies, and now we're at the point where we can start to evaluate which theory can explain which empirical data. So the claims by Doric is, just to summarize here, consciousness can be approached from a purely empirical stance. And there's a lot of theories of consciousness, TOCs, and that suggests to Doric that, and colleagues, that there are stringent criteria are lacking. There's a lack of stringent criteria for defining if a theory is good or not. And the paper represents what they call a stepping stone. So it's not a final product. They want to make a suggestion as to how we could build these criteria and provide a compass to locate which theories of consciousness, TOCs, in the space of these criteria, which theories can live up to or cope with these criteria. And not all theories of consciousness can be correct. And the goal is to reduce the number of theories of consciousness. So the idea behind this article by Doric et al. Is that we should be able to go through all of these different theories, and here we have them in these columns here, all of the different 13 different theories, and then assign and figure out if all of the different criteria in consciousness research, if they can live up to these criteria. So here you probably know a few of them, and that is, for example, recurrent processing theory, RPT, or we have HOT, higher order thought theory, we have global neuronal workspace theory, and integrated information theory, which you already know. But then there are these other theories. And what Doric points out is that different theories of consciousness explain different aspects of consciousness. And if we set up criteria for TOCs, theories of consciousness, we can compare how different theories account for all criteria. And by defining which criteria a theory of consciousness cannot address, then those proponents of that theory can develop it further and see if they can define how that theory should account for that criteria. So before we see this in action, we're going to need a bit of a background, and this might reiterate something that you've already learned. So states of consciousness and content of consciousness is a very important distinction in consciousness research. So an example of a conscious state could be the difference between being awake and being asleep, or being in a coma. So that is a state difference. And an example of a difference in content is, for example, did you see this visual flash or not? Did you see this visual presentation of the stimuli or not? That's a difference in content. Another cool way to look at differences in content is using this paradigm called Binocular Rivalry. And so in this paradigm, what happens here is you can present different information to the left eye or the right eye, and this actually means that you will you will switch between having a perception of what goes into your left eye or having a perception of what goes into your right eye. And you can actually see this when you perform this floating finger illusion, where you sort of put your fingers up in front of your eyes. This is due to binocular rivalry, that there's this your one eye is perceiving one thing and the other eye is perceiving something else, and together it becomes a sort of a battle between which percept you sort of have. And this you can do in a way where participants or observers will switch between what they perceive from the left eye or what they perceive from the right eye, and that is a difference in content. And what Doric and colleagues do is to say this distinction between states and content of consciousness is very important in the empirical literature on consciousness. And it should be something that a theory of consciousness should be able to reflect, to be able to explain, meaning that TOCs, theories of consciousness, should be able to explain this difference. They should be able to describe how consciousness can both differ as a state and differ as a content. So if we go back to the criteria, and we can see what this is actually something that Doric calls a scope, meaning is it something that the theory is set up to be able to explain. And here Doric and colleagues claim that this theory here, which is in NDT, neural Darwinism theory, that theory is unclear about how to address the issue of state versus content. So that theory doesn't explain properly what how consciousness can differ as a state and how consciousness can differ as a content. Whereas if we look at the theories that we have been discussing here, IIT, recurrent processing theory, global neuronal workspace, and HOT, they all can describe the differences in state and content. They can both, all those theories can describe the difference between being awake and being asleep, the difference between perceiving what comes from your left eye or what comes from your right eye. But neural Darwinism theory, NDT, cannot. And that becomes a way to say that this theory has doesn't live up to this criteria. Okay, so let's look at another criteria. So this criteria is what Doric calls, it is tied to a type of argument that Doric has been and colleagues have been proposed before, which is the unfolding argument. So the unfolding argument is particularly aimed at recurrent processing theory, RPT, and integrated information theory, IIT. So these two theories, if you remember, were all about causal structure. For RPT, it was that these early areas feed forward into later areas and then loop back into the early areas again. It's a causal system, and it's claimed that this causality is necessary for consciousness. For IIT, the causality is also very important. Integration is dependent on this repertoire of causality, of cause and effect structure. So both theories are sort of causal theories of consciousness. Doric claims, however, that for example, if you have this recurrent network where there is recurrency in the network and integration in the network like this, you can actually unfold that network and create it as a fully feed-forward network, and as sort of take this recurrent network and fold it out, so it still has the same input and output function. And so according to Doric, for every recurrent network, there is an equivalent feed-forward network. And what, according to Doric, when you compare all the theories and look at can they resolve this unfolding argument, then the RPT and the IIT cannot account for or cope with the unfolding argument. And this is in contrast to the two other theories, global neuronal workspace and HUT, which according to Doric can account for the unfolding argument. So this becomes a way to say that these two theories cannot live up to this criteria. Then another criteria where Doric points to an article by Herzog from 2007, who argue that some TOCs allow for consciousness to exist in small networks. Some of these theories do, whereas other theories don't allow for consciousness to exist in small networks and only allow consciousness in larger networks. So this is actually, Doric claims that this is actually the most of the theories that we went through can't cope with the small network argument. So recurrent processing, IIT, and global neuronal workspace cannot explain consciousness in small neuronal networks. For example, global neuronal workspace claims that consciousness is this broad global broadcast that's spread out by the workspace in the brain, and so there's no effort in the theory to account for consciousness in small neural systems. But actually, the HUT is, as explained by Doric, has, for example, the capability to explain consciousness in small networks. Although Doric claims that there are some authors of HUT that have different takes on what constitute a higher order thought state, and therefore some of these proponents of HUT theories, some of their accounts actually don't allow for consciousness in small networks. So that's why this is orange here. This orange box here is because it depends on the interpretation of the higher order thought network. So the last criteria that we will go through here in this session is really interesting. And this is called the multiple realizability argument. And consciousness as a mental, the question is, can consciousness as a mental property or state be implemented in different physical systems? So in philosophy of mind, there is this thesis that the same mental property or state or even event could be implemented in different physical properties, states. So the question is, does a particular TOC allow for consciousness to be implemented in different physical properties? And here, if you remember back to IIT, for example, that theory actually allows for multiple realizability. A conscious mental state is just, does it fulfill the physical properties of integration, which could be fulfilled by an AI systems, which could be conscious according to IIT. So integrated information theory allows for multiple realizability. Higher order thought theory does not allow for multiple realizability. And therefore it has some problems. There's some variants of higher order thought theory that allows for multiple realizability, but most of them don't. And this is where we will discuss one of the most interesting cases in neuroscience. And this is a study by Folliet in an article called The Brain of a White-Collar Worker. So this is a very interesting case, maybe one of maybe the most interesting case in all of neuroscience. So this was a 44-year-old man who came to the doctor, and he had had 2 weeks of left leg weakness when he was 6 months of age. And he had when he was 6 months of age, he had a condition known as hydroencephalitis, which is the buildup of water in the ventricles, which are these ventricles are these large aqueducts of water that sort of clean waste products from the brain. And he was treated for this as a child. So at 14 years of when he was 14, he had developed some problems in his left leg with ataxia, it's called. And but now he was healthy. He is a father of 2 and worked as a civil servant. He has a normal IQ, a bit on the low range, but no major intellectual sort of problems. And then when they took an MR scan, his brain, they found this massive enlargement of the ventricles. This massive enlargement of water, you could say. They were so large that they had likely pressured most of his brain cells out into the very edge of his skull. And you can see this very thin cortical mantle here, and very large ventricles. And this is very extraordinary. Now, this poses a lot of questions, because you remember there are so many examples of localized brain regions that you've learned about. This area of the brain processes this area, the fusiform face area processes faces, amygdala processes fear, and so on. This individual, he might have those regions, but those regions are not in the same place as a normal or neurotypical individual. They have been relocated or pushed to the edge of the skull. But clearly still, even though this person doesn't have that brain region localized in that same place, this individual lives a normal life. He has a job, he has a social life, he has 2 children, he has a wife. And this man would clearly, if you spoke to him, he would claim that he is conscious. So a theory of consciousness would have to explain why, if a theory of consciousness requires that some brain area is required for consciousness, then that theory would have to explain how it could be that brain area is not where it is usually is, and that would pose a problem for that theory. So according to Dorig, this is a problem for higher order thought theory, which proposes that particular brain areas become aware of other areas. If then that area, which is supposed to become aware of another area, is located in a different place. And this is the reason for this red box here, or this orange box here, and that higher order thought theory has trouble with explaining. So in sum, these hard criteria for empirical theories of consciousness, there are lots of theories of consciousness, TOCs, and Dorig et al. From 2020, they propose these hard criteria for consciousness theories, and using this framework, it can be evaluated whether theories of consciousness can live up to certain criteria, or where certain theories need to be further developed. Thank you.